How many lines of symmetry does a square have? So if you think about a square, all four sides equal, all 90-degree angles, you can draw lines of symmetry up and down, side to side, and both diagonals. So there's 4 lines of symmetry. What is the angle of rotational symmetry of a square? So I'm going to draw a square again. The square has 4 angles that are equal. So the angle is going to be 360 divided by 4, which is 90 degrees. So if you turn it 90 degrees, it's going to match up. Number 3, how many lines of symmetry does a convex regular pentagon have? So a pentagon that's regular has 5 lines of symmetry, all the perpendicular bisectors of each side. I didn't even do that right. It's going through the vertices. I'm going to draw this again. I don't like that. Okay, so if you draw a pentagon, I'll do it nicer. 1, 2, 3, 4, 5. Go from each vertex to the perpendicular opposite side. That's how many lines of symmetry it's going to have. So it's going to have 5. There, this one looks better. So if you had a hexagon, then you'd have 6. If you have a heptagon, you'd have 7 lines of symmetry, as long as it's regular. And then what is the angle of rotational symmetry? So again, I'm going to draw a pentagon. It has 5 congruent angles. So you could turn it 360 divided by 5. So you could turn it 72 degrees. And then number 5, this one has 3 of these parts that are equal. So if you turned it, you do 360 divided by 3. The angle of rotation is 120 degrees. Number 6, sketch a figure that has rotational symmetry but no lines of symmetry. So I'm going to take the Mercedes emblem up here. You know, this has linear symmetry, lines of symmetry right now. So just to make it so it doesn't, I'm just going to put something like this. So now I can no longer do it. It has this spoke thing coming off it, each side, so now I can't draw a line. If I drew a line like this, it would no longer work because these two wouldn't line up. As long as I put them on the right-hand side, right-hand side, right-hand side, then it works. Okay, number 7. Determine the scale factor and center. So the center is, you start at the same point, E and E, and I connect E to E prime. And then I connect F to F prime and make a line. Then I connect G to G prime and make a line. Then I connect H to H prime and make a line. So where they all come together is a center. So the center is at -2, -2. So for the scale factor, I'm going to compare the distances between the center of the dilation and the pre-image to a new point on the image, or image to pre-image. So if I look at, let's look at EH. So the distance between EH is 1, 2, 3, 4. This distance is 4. The distance between E prime, H prime is 2 units. So what I did is I went from EH, this is the pre-image, to the image. So what did I do from 4 to 2? Well, I multiplied it by 1/2. Or you could take the image and then divide it by the pre-image. So 2 divided by 4 is 1/2. So the scale factor is 1/2. So it wouldn't work if you just looked at the coordinates for this one because the center is not at 0, 0. Normally we could just look at the coordinates and see how do you go from x to x prime, but this time the center is not at the origin. Okay, number 8. A model plane has a scale of 1 to 20. So that means that 1 is the model, and then 20 is the plane. the real plane. If the wings of the model are 4 inches, how many feet apart are the wings in the real plane? So they want us, so we have 4 inches right here, and this is 4 inches. So you could do 4 inches and compare it. If I multiplied this by 4, then I have to multiply this by 4 too. So 4 inches is 80 inches. So then I'm going to convert this to feet. So if 4 inches is 80 inches, then how many feet is that? So I'm going to do how many, so I take 80 inches and divide it by 12 to get the number of feet. So 12 goes into 80 6 times, because 6 times 12 is 72, with 8 left over. So 6.812 is 2/3, so 6.6 repeating feet. And then demonstrate with matrices. So remember, it says with matrices how to dilate this by a scale factor of 6. So I'm going to set up a matrix for ABC. So my matrix is going to be 4, 5, -6, 8, 1, -2. I'm going to multiply it by a scale factor of 6, so 6 goes on the outside. So then what I do is I just multiply everything through by 6. So it's going to be 24, -36, 6, 30, 48, and -12 are the elements. And then if you had to graph it, just make sure that you write these as ordered pairs. So 24, 30 would be A prime. This would be B prime. This would be C prime. Okay, number 10, find the image after a dilation of scale factor 2. So this means that the scale factor is 2, you're going to double each one of these. So A prime is going to be -2, 4. B prime is going to be 0, 6. And then C prime is going to be 4, 6. So you want to graph both. So I'm going to graph the image, or the pre-image first, is -1, 2, A, 0, 3, B, 2, 3, C. And in the pre-image, do each point, or in the image, do each point and make sure that you put a prime. So A prime, B prime, C prime. We're over here, oops. 4, 6. So A, B prime, C prime. Okay, number 11, find the center and the scale factor. So again, you're going to connect, this one would be better to have a ruler here. You're going to connect A and A prime, make a straight line. B and B prime, make a straight line. C, C prime, make a straight line. Okay, so then this time their center is at 0, 0. And the scale factor, what you're going to do is look at, this time we can look straight up at coordinates and not necessarily distances. Well, actually, let's just do distances because these look like even. So I'm going to count, this is my image. I'm going to take my image and divide it by the pre-image. So the distance between here to here is 10 units. And I'm going to divide it by the distance between here to here. You're going from 3 to -2. So that is 5 units. So 10 divided by 5 is scale factor 2, which this figure is twice the size of this figure. And then number 12, in your first name, which letters have rotational symmetry? Okay, my letters don't have rotational symmetry. If I would turn the E, it would be going this way. So this one doesn't. If I turn the M, that wouldn't either. And then actually the I does. The I has the only one that has rotational symmetry. It has 180 degree rotational symmetry. The L doesn't and the Y doesn't. Now I'm going to draw Emily again and do line symmetry. So this has a line of symmetry, this has a line of symmetry, this has two lines, and the Y doesn't, depending how you write it. If I would write the Y like this, it would have one line of symmetry. But if I write it like this, it doesn't have any. And then the last one, a model house has a scale of, this time we have units, last time we didn't. 1 inch is 2 feet. If the real house is 26 feet wide, I can write a proportion for this. So 1 inch is to 2 feet as, if the real house is 26 feet, so I do put 26 feet on the bottom, how wide is the model house is to X. So I'm going to cross multiply like this. So 1 inch times 26 feet equals X times 2 feet. Divide both sides by 2 feet. Feet cancel out. And then 26 divided by 2 is 13. And then I have inches. So it's X equals 13 inches. That's my answer.